Good morning, everyone. I'm Rahul and I will be presenting our research project titled Real-Time Attention Span Tracking in Online Education. This is the general overview of the presentation. We all know that due to COVID-19, most of the schools and colleges all over the world are closed. And this has led to a massive shift from traditional classroom education to online mode of education. While online education has a lot of advantages, it still has its own disadvantages. For example, in online education, it is very difficult for a teacher to monitor over 40 students and check whether they are paying attention to the lecture. Recently, I took the graduate record examination and they have introduced the option of test from home, in which every student will be assigned a human proctor who will be monitoring the students using their camera and microphone input. Both these are time consuming processes and are not efficient. So, we thought why not automate this process of monitoring students using artificial intelligence. These are some of the problems in online education. Mainly, the current system of online education is mostly based on marks. Students can easily skip lectures and copy answers from the internet and still get very good marks. Also, the students can use proxies during exams. That is, he can ask someone else to write the test for him and get marks easily. What is the actual knowledge gained by this type of education? This not only affects the learning capacity of the students but also produces low skilled laborers in the future. Our goal is to build an intelligent system to monitor the students automatically using non-verbal features from the web camera and microphone input. Based on the literature review, we have identified 5 features to assess the attention level of students during online classes: blink rate, eye gaze, emotion, body posture, and environmental noise. Also, we have implemented facial recognition to avoid proxies during online exams. This is the overall architecture of our proposed system. We will be extracting each and every frame from the webcam input, and the first step is face detection. Then we will have to verify the detected face with the student database using facial recognition. Once the face is matched, we will be extracting facial landmark features and these will be given as inputs to other modules. We have 5 different modules and we have used the concept of multi-threading to enable parallel processing instead of sequential processing. Based on the scores assigned to these parameters, we will calculate the overall attention level of the student for that particular frame. Similarly, we will be doing this for every single frame and we will also generate real-time graphs for these scores. The first module is facial landmark detection. We have used Euler-Jones algorithm for face detection and OpenCV's dlib library to extract 68 key points including eyes, eyebrows, nose, mouth and jaw. The second module is face recognition. For this, we have implemented a 3-layer convolutional neural network with sparse representation classifier as the output layer. This neural network will essentially learn the sparse and selective facial features which will be used to match the face with the database. The third module is blink rate detection. We will use Euclidean distances between the 6 key points of the eye to calculate the eye aspect ratio as shown in this formula. Based on the EAR value, we can determine whether the eyes are opened or closed. Also, we have implemented a mechanism for drowsiness detection, which will keep track of the number of seconds the eyes are closed, and if it exceeds 2 seconds, it will automatically trigger a warning message and an alarm sound. The fourth module is eye gaze tracking. We will use the eye region and scan for rectangular features to identify the pupil position. Based on the pupil coordinates, we can determine the eye gaze direction to find out whether the student is actually looking at the screen or looking somewhere else. The fifth module is emotion classification. Here we have used the extracted facial landmarks to train a support vector machine, which is the machine learning algorithm, to classify the emotions into 7 classes. These are grouped into 2 categories of emotions. Happy, surprised, and neutral denote a constructive learning experience, whereas sad, fear, anger, and disgust denote a negative learning experience. The sixth module is body posture estimation. We use the TensorFlow's pose estimator, also known as PoseNet, which is based on MobileNet SSD single shot detector, and it can identify up to 17 key points to determine the posture of the student. We assign a pixel similarity score by comparing the change in posture between frames, and based on this we can determine whether the student is focused or restless. The final module is background noise detection. For this we have used PyAudio, which is a Python library to detect the sound from the microphone input. The average sound level in a school environment is 50 decibels, and anything above 75 decibels is considered to be a noisy environment and is not favorable for learning. We normalize all the scores assigned for each of the parameter between the values 0 to 1, and based on the normalized scores we calculate the attention score using this formula. We also plot a real-time graph which is updated for every 5 seconds. These are some of the visualized output graphs. Also, we provide information about the duration for which the student was attentive during the class. Here is one of the sample reports for 3 students, and as you can see at 40 seconds, the attention level of the students, all the students were low. So that means there was some problem with the lecture content at that particular time, and the professor can use this information to review the lecture content and improvise the teaching standard. We asked 15 undergraduate students to attend online classes on different topics, and we recorded the whole session including the webcam and microphone input. Similar to GRE human proctors, we assigned 3 human observers to monitor the students and provide an observed attention score based on their behavior. The observed attention score is used as the ground truth value, and for performance evaluation we will be comparing the observed scores with the predicted attention scores. The comparisons results are shown in the graph, and the table shows the performance metrics of our model. As you can see, we have got low values for root mean square error, mean absolute error, R square error, and mean absolute percentage error. This means that our model was able to perform good given the limited amount of data used for training. The table represents the accuracies and inference times for each module and also for the system as a whole. We achieved an overall accuracy of 84.62% and an inference time of 0.258 per frame. To conclude, we built a system to monitor the attention level of students in real time and evaluate their performances based on the actual learning process instead of just academic scores. We used 5 parameters to calculate the attention score, and also we have implemented facial recognition for authentication and automated attendance. We also generate real-time feedback in the form of live graphs, which can be used in 3 ways: to analyze the overall performance of the students, to improve the teaching standards of the teachers, and to avoid cheating during online exams. As of future works, we can improve the performance of our system by using more data for training the models. Also, we can extend the system to work with multiple students in a classroom by integrating our system with Zoom meeting or Google Meet. And currently, we do not have a standardized data set for attention level of the students during online classes. So we have used the human observed scores as ground truth value, which might not be that much reliable. So if we can get access to such a data set, it will be useful for evaluating our system's performance. Thank you.